Okay, magandang hapon, Tagala konten lang, so we better do in English. But thank you to Norcham for inviting Seaborg to present our molten salt reactor and our nuclear power plants, as Jesper introduced. And I heard they need a lot of power for the farming. So I will present a high level of our technology. So Seaborg was founded in 2014 by 5 Danish nuclear physics, and they had an idea of using molten salt reactor, which is the generation 4 nuclear reactors. So sitting in Denmark is not easy, but they decided they had so good idea that they wanted to start a company. And our company is privately funded and privately held until now. And our headquarters is in Denmark, Copenhagen, where we have a now office here in Korea, where I am based most of the time. And then we have in Singapore also. We have scaled over the last year, or last 14 months, we scaled from 25 people to more than 100 people. And we have 26 different nationalities who have actually moved to Denmark to help with this project. And we plan to be up to 150 by the end of this year. So what is it we are building? The compact molten salt reactor is what we are building. It has a unique feature. So I will compare to a normal nuclear power plant. A molten salt reactor operates at atmospheric pressure. That means there's no pressure inside the vessel. Compared to a traditional nuclear power plant where you have several hundred bars pressure. So when there's no pressure, it cannot melt down and explode. There cannot be an explosion. It will just run out and stay on the ground. And therefore, it can also not release gases into the air. It will stay within the containment. And lastly, which is not so much with the environment, but it cannot be used for nuclear weapon. You cannot produce a plutonium and weapon-grade material. This is something where you can be limited by where you can expose it, where you can use this technology. So we don't have any limitations on this. Seaborg has chosen to fuel each reactor for 12 years operation at 100% operation. Means when you get a reactor and a power plant, you already have the fuel on board for the next 12 years. So it is comparative, you bought all the coal for 12 years at the same time. We call it safety by laws of nature. The key component is really the fluoride salt, which we use. That is a rock in nature, as you can see down here to the right side. And it will melt, when you heat it up, it melts at about 490 degrees, and it boils at 1500 degrees. And it is actually behaving like water. It is same viscosity, it's much heavier, but it's the same viscosity. Our reactor operates at about 700 degrees, so we are well below the boiling points. As you can see here, this is from one of the laboratories in Denmark, in Copenhagen. We have several laboratories working on individual tests and loops. I need to give a little bit background on the molten salt reactor and why we founded the company. The picture here is actually Glenn Seaborg, who I wouldn't say invented, but at least he found plutonium in the 40s and 50s. He dedicated his life to peacefully nuclear since then. And he was part of the test in the early 60s. The molten salt reactor has actually operated 3 times. First time was in 54, short time. The second molten salt reactor was from 65 to 69, and it was operated in the Oak Ridge National in US. And third was in China, and we also know that China is actually ahead of everybody, including us. They started the fourth molten salt reactor this year in China. The design is actually very similar to that time, and a lot of the data is still valid. So that experiment, that proved a lot of the design criteria, a lot of the design behavior is quite practical. But there was one item which was problem, and it's called graphite, and we use that for moderator. I will not go into the technical detail, but for the type of reactor we make is called a thermal reactor and not a fast reactor. You need a moderator. So this is what Seaborg spent a lot of their time and the initial study why and how was it not commercialized that time. And they, or Seaborg, have come to the conclusion that graphite is the real problem. And you can see a picture of the graphite on the right side. This is inserted in these small tubes or in the part of this. The problem with graphite is that it cracking or swelling or breaks when it is under irradiation, and it will be under heavy irradiation inside the molten salt reactor. The problem is that you cannot say whether it lasts 3 months, 6 months, or 3 years. And therefore, it's difficult to make a business case because this is really, really difficult to replace this. I would say I will go to that far. In our concept, you would not be able to do it on site. So Seaborg have developed a new moderator where we don't use graphite. So we have decided to use sodium hydroxide, which is drain cleaner. It's known from that part, and this is an excellent moderator. And it is also liquid from around 300 to 1400 degrees, well within our same area as our fuel salt. So this is just to show you that the fuel salt is in the pipe and the moderator is on the outside. This is where the graphite used to be in a similar way. That is, of course, giving new challenges because sodium hydroxide, you probably know, this is highly corrosive, and therefore we need to verify and find a way of doing it. And we spent years on this part. So last year, we were very confident that we had a proven technology to control corrosion in the sodium hydroxide circuit. And we have come to another findings, which is sometimes when you develop new technology and you find, oh, this could also be used for something else. In our laboratory and our test, we found that sodium hydroxide is actually an extremely good medium for energy storage. You can install it at higher temperature. So we actually established Jaime as a sister company in December last year, and they are now in the process of building a pilot plant in Denmark, in Esbjerg, to prove that the technology for energy storage. It gives a good synergy between them, but it's also a way of getting this to another important market where you are lacking energy storage for the increasing renewable energy. So much about the technology on a high level. I want to talk more on the power barge, which we are developing. So first, I need to explain why we have chosen a total, and Jesper nailed it by saying revolutionized idea of making sure we can scale the production of the future nuclear power. A traditional nuclear power plant, as you started in Batam in Philippines. I stayed 10 years in Philippines, so I know a little about that area. There was some attempt to build one at that time. The problem with these are, first, they are very big today because they need to be safe and they have developed to large size. But the most problem is they are built on site, means everything is shipped to that site. And to actually build them, you need highly skilled labor and people. And these are often not available in that location. And generally, they are also not very close to a city. So people have to move there even from abroad to stay there for many years, 5, 7 years, to build it. And therefore, it is nearly impossible to scale this. So our revolution to the energy supply is Seaborg have sub-suppliers which we work with, for example, pumps, heat exchangers, valves, instrument, etc. We make agreement with each supplier and they deliver to our factory. We plan to build at least the first 20 reactors in Denmark. So we assemble all these components and put them in a container. Our reactor kind of fits in a 20-foot container, but it will probably need a 40-foot container to send it. It's the kind of size of the whole reactor, much smaller than traditional. We will ship it to Korea, where Samsung Heavy Industry, we have partnered with them. They will build the power barge itself, and they install the reactor into the ship. Similar to what you do with a boiler for a ship or a main engine or gas turbine. This is just a reactor, it's just a heat source. And then we fuel it and test it in Korea. And then we've transported, for example, to Philippines, where we connect to the local grid. And the size of the barge is typically matching to the local grid. So if it is island, which are not, then you choose a smaller one. And if it is a bigger grid, you can choose a bigger one. That is the fundamental for our revolution and difference from traditional nuclear power. We build everything in Korean shipyard in Samsung, in fact, and therefore you have the skilled people on site all the time. Inside the power barge, up in the right side, you see a power module. We call it a power module, 200 megawatt electric. And this is to the grid after we have consumed our own power. That power module is seen here from the top. Each reactor, as I mentioned, runs for 12 years. So we install 2 reactors into the forward end of the power module, and these run for 12 years. And then we, after 11 years, we install 2 new reactors, which are then fueled and started, and they run for 12 years. And the turbine and generator is expected to run for 24 years. The lifetime of the power barge is 24 years. And after this, I will come to that in the next slide, we will actually remove the entire power barge and take it to a decommissioning shipyard. So there will be nothing left on the original side. This is showing a little on how the reactor is shielded to the environment. It will be too much to come into that technical detail. So remember, there was a power module of 200 megawatt. Seaborg and Samsung has chosen 400, 600, and 800 is our maximum available floating power plant. But each of these are still the same 200 megawatt power module. And of course, some will ask why not make it bigger, but we want to make sure that each power module is just serial produced for like a Hyundai car, or you can also imagine a container ship. You want to do it efficient, but it also gives you, if you have a larger power plant, it gives you redundancy. So each of these modules can operate independently of the other. They don't require the other one. So this is another revolution on this. Of course, nuclear cannot be talked about without waste. and decommissioning. As I mentioned, we will move the power barge to the decommissioning shipyard 24 years later. And now we have a spent fuel, but compared to a traditional nuclear power plant, the spent fuel is in a rock. Traditional is in a high pressure rod, and it cannot easy to take out. The plan in the decommissioning yard is that we take this rock, we reprocess this thing, and we can then recycle the spent fuel in another molten salt reactor, in one of our next molten salt reactor. Technically, it's possible today, but legislation and towards proliferation, it's not yet in place. But after you have put it into our molten salt reactor for another 12 years, the waste then only need to be stored from 300 years, around 300 years, compared to 100,000 years. So this is the kind of whole loop against not only delivering, but also taking it back. So the plan is develop this in Denmark and build it in South Korea and then power the world. And of course, the main focus is to build for electricity. This business model make it actually scalable, and it is not unrealistic in the mid-30s to build several hundred power barges per year. People also ask about regulatory, and of course, how do we get it approved? There is many limitations or many rules for this. By taking the floating maritime approach, we are working with ABS, and that allows us to use the maritime approach, where ABS is an American company. They have excellent knowledge on nuclear power and nuclear regulation. They work closely with the NRC in the US. We started working with them in 2019. We received what we call technology feasible study or a certificate in July 2020. And we are working on the next process, which is, of course, a much more comprehensive. And there is about 5 steps until it is fully operational. But just working on the maritime, that is very short explain. You are under the IMO rules, and you of course have to fulfill IEA, and we use ABS. The key thing is we need a flag state. So we are looking at Singapore, and Singapore is a good candidate, but it could be any other country. They will have to have some regulation in place for nuclear. And then we have the owner who buy this power plant and, for example, bring it to Philippines. So the whole power plant comes with the nuclear legislation and approval to be anywhere in the world. The local authorities in the Philippines, if it was in the Philippines, can add additional requirement on top of this. And they probably may have some, but they don't have to develop the complex regulation scheme. It's a very high level, but it's important to understand that you, by doing it with the maritime, you remove a lot of the obstacles which is prohibiting developing countries of getting nuclear power today. Power to X, it's not only electricity. Actually, electricity today is 20% of the total energy market. And we expect that will increase with the solar and wind to maybe 40% over the next 10 years. But you still have a lot of other industry like ships and like heavy industry, and who need the power. And that is not easy with electricity. So by using our power barge to make hydrogen, we can make clean hydrogen. That is one of the problems today, that hydrogen is not clean. It still pollutes the same. Then from hydrogen, you have the ability to spend ammonia, make ammonia, methanol, but you can also in steel production. I think don't count me on it, but it's around 3% of the total pollution in Korea is from POSCO steel production. So that can also be replaced with hydrogen. And then, of course, using in cars and buses and airplanes. So this is opening up for that market. And by, as you could imagine, that ship, we can actually build up to 800 megawatt. We can move it either on a heavy lifter or it can be towed to, for example, Philippines. Our footprint is very small. It's not big compared to all other kind of energies for producing the amount of power. So I think that was a very high level introduction to the two things, our reactor and our power module and power barge. And of course, Philippines is of interest to us, particularly as Jesper briefly mentioned, there's a lot of island and there's the grid doesn't have to be made big to accommodate ours.